Today we're going to technically review direct variation and talk about inverse variation. Direct variation, I don't know if you remember this, but it's a phrase like y varies directly with x, y varies directly as x. It's the equation y equals k times x. This equation, it kind of looks like a normal slope equation, like y equals a slope times x, but there's no y-intercept. So direct variation always goes through the origin, and x is going to get bigger as y gets bigger. One example of direct variation is like x is the number of cloudy days and y is the number of days with rain. Would it kind of make sense that if there's more cloudy days, there's probably going to be more days with rain? So that's a direct variation situation. The other one that we're going to learn today is inverse variation. Inverse variation is the equation y equals k divided by x. And I don't like how that's written. I'm going to write it over here. Y equals k divided by x. So direct variation is k times x. Inverse variation is k divided by x. K is called a constant of variation. So in each situation, there's a specific k value. So here's an example. xy equals 4.8. I want to get y by itself, so I'm going to divide both sides by x. We have y equals 4.8 divided by x. Does that look like direct variation, inverse variation, or something else? Inverse. The next one, x and y are kind of like on the wrong side. It's x equals instead of y equals. I want to get y by itself. Currently, we have divided by 1.5, so I'm going to multiply by 1.5. And that will give me 1.5x equals y, or y equals 1.5x. Does that look like direct, inverse, or something else? Direct. Number 3, y is already by itself, but do you see the plus 5? That plus 5 makes it neither. And then number 4, we can simplify 9 divided by 3. Like this kind of looks like inverse variation, but anyway, what is 9 divided by 3? 3. So really this is 3 divided by x. That is inverse variation. Oh, there's another one down here. 3y equals 4x. If we divide both sides by 3, if it's written like this, it's kind of weird looking. What if I write it this way? 4/3 times x. Just because there's a division bar doesn't mean that it's inverse variation. What I want you to notice about inverse variation is that x is on the bottom in inverse variation. In this example, x is not on the bottom, x is on the top. It's 4/3 times x, or you could change that to a decimal, 1.33 times x. That would be direct. Before we tackle the tables, I want to show you a little trick involving tables. So if I were to take direct variation and try to get the k by itself, if I wanted to get the k by itself, I would divide both sides by x. So k is going to equal y divided by x. This is where using your notes this year is going to be incredibly helpful, because in previous years, people had to memorize this, and I'll admit this is kind of weird to memorize. In inverse variation, if I want to get k by itself, I would multiply x on both sides. So k would equal x times y. K is a constant number. So in these tables, K needs to be the same number every single time. So if I do my y values divided by my x values, and I get the same number every single time, then it's direct variation. If I do my x values times my y values and get the same number every time, then it's inverse variation. So first we're going to check to see, is this direct variation? We're going to do y values divided by x. 1 divided by 3 is 0.33. 0.5 divided by 6 is 0.0833. Are those numbers the same? No, so it is not direct variation. Then we'll check inverse by multiplying them together. 1 times 3 is 3. 6 times 0.5 is 3. 10 times 0.3 is 3. And 12 times 0.25 is 3. So this table is showing us that there is a K value of 3. We could honestly right now say, hey, this is inverse variation and K is 3, so the equation is y equals 3 divided by x. That's the equation for that table because it's inverse variation and the K value is 3. We're not going to go that far, but that's what you could do. So number 6 is an example of inverse variation. So in number 7, first I want to check, is this direct variation? I check to see if it's direct variation by doing my y values divided by my x values. So I'm actually going to go back up to the top of my notes and say, to check for direct, do y divided by x. And then for inverse, to check for inverse, do x times y. So it seems kind of backwards, but that's because we're really doing inverse and direct variation backwards to see, is there a constant K value? So we're checking to see if y divided by x gives us a constant number, then it's direct. If x times y gives us a constant number, then it's inverse. So in number 7, I do 12 divided by 3, I get 4. Then I do 32 divided by 8. What's 32 divided by 8? 4. It's looking like this might be direct variation. 44 divided by 11 is 4. And 2 divided by 0.5 is 4. There's no need to check for inverse variation because we just found that it is direct variation. So number 7 is direct. If you wanted to, you could say y equals 4x because that's a direct variation equation with an K value of 4. Number 8, I'll bet some of you can already guess what number 8 is going to be. First, we're going to check direct, doing y divided by x. What's 6 divided by 1? 6. Then we do 5 divided by 2 is 2.5. Are those numbers the same? It's not direct variation. Then we'll check inverse. To check inverse, you do y times x. 1 times 6 is 6. 2 times 5 is 10. Are those numbers the same? So what is this one? Neither, 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 something else. In these problems, there's basically 3 parts. The first part is find the constant of variations. That's going to be part A. Part B is write the equation of variation. And then part C is going to be find y when x equals 2. So it says y varies inversely as x. Y varies inversely. That means y equals k divided by x. It's telling us that y is 9 when x is 4. So I'm putting 9 in place of my y. I'm putting 4 in place of my x. Now I can figure out what k is. How do I undo divided by 4? Times 4. And 4 times 9 is 36. So part A, find the constant of variation. The constant of variation is 36. Part B, in this one it says write the equation of inverse variation. It will often say something like write the equation relating x and y. So for part B, we need to actually write out y equals 36 divided by x. A lot of people forget that step. They find that k is 36 and think they're done. Make sure you actually write the equation. So you're going back up to this thing and putting what we just found our k value to be in there. Then part C, find y when x is 2. They're saying plug in 2. So if x equals 2, what is 36 divided by 2? 18. That would be part C. So part A, figure out what k is. Part B, write the equation using that new k value. Part C, plug in some other number. Number 10, I'm going to throw you for a little bit of a loop. It says y varies inversely with the square of x. Inverse variation is k divided by x. Y equals k divided by x. But this time they're saying y varies inversely with the square of x. That just means you stick a little squared on your x. Then they're telling us that y is 5 when x is 4. What is 4 squared? 16. And then we would multiply both sides by 16. 16 times 5 is 80. So part A, find the constant of variation in this new inverse variation situation. Our constant of variation is 80. Part B, write the equation. You're going back to this thing, but now we know what k is. So y equals 80 divided by x squared. Part C, find y when x equals 2. So plug in 2. What is 2 squared? 4. And 80 divided by 4 is 20.